Hi everyone, I'm Josh Chenevier, and I'm going to give you a quick demo of fast graph traversal in AllegroGraph using JavaScript. So this prototype is called Jig, and it's meant to be similar to the Tinkerpop graph traversal languages Ripple, Gremlin, and Pacer, except that this one uses JavaScript syntax and it compiles to Lisp, which runs very efficiently in AllegroGraph's Lisp environment. So when I execute the script, I'm sending a JavaScript file to a remote server, which is running AllegroGraph and compiles it to Lisp, and after that I program as if I'm in a JavaScript environment, but I'm actually executing Lisp programs. So it's stateful. There's a special constant in this case called store, which contains a drug bank dataset that I've loaded in for the demo. It's about 9 million triples. So we can begin to explore these triples using path expressions. So if I say g triples, that would give me all triples, but I'm only going to take the first 10. And here you can see a bunch of statements or edges in the graph, all of which have al same as the label in this case. I can make that a little more clear by adding label to the end of my path expression. But I'd like to find a few more predicates, so let's expand that limit all the way out to 100,000 and then just eliminate any duplicates. So this will take a few seconds to run, but you can already tell that it's running a lot faster than it would in a JavaScript interpreter. So we found 250 labels or predicates. Let's say I'm interested in RDF type up here. That's number 6. So I'll pull it out and give it a name, type. And then with that, I can refine my query as follows. G triples, null, a wildcard, type, null. So that'll give me all the edges with a label of type. And I'd only like to get the head of those edges or the object of those statements. So I say head. Again, I'm going to give it a big limit. And filter out any duplicates. So this will give me a list of distinct types. We have genes, we have drugs, we have targets, we have secondary outcomes, whatever those are. Let's say I'm interested in drugs. Drugs is this one. And now I'd like to explore the neighborhood of drugs, so I put drugs into a pipe and I say get me all the edges going into drugs that have the label type, and just give me a few of those. And I will call that D. So here are a few different drugs. Actually, I meant to add a tail to that so I'd only get the vertices, not the edges. So there we have some drugs. We can look at them individually, or another thing you can do is to compare them in different ways. For example, G common D0, D9 will give me a list of nodes that lie on shortest paths between D0 and D9. That's built-in functionality in AllegroGraph, but it's equally easy to define your own functions, and they run just as fast. So one that I've defined is nearby. So I need G V of D0. Nearby, I'll go out 2 steps, and then I'm going to aggregate the whole thing into a ranked list or a vector. So that's going to give me all the GV nearby 2 aggregate. Oh, extra bracket. Sorry about that. That's going to give me a ranked list of everything that's nearby to drug number 1, where the weight indicates the number of paths there are between drug number 1, number 0, and any of these vertices. So I'm going to give that a name. I'll call it D0. And we'll do the same thing with another drug, maybe D9. That's one I used before. So now we have, that's a lot of results, 2 ranked vectors, and we can do various things with them. We can, for example, intersect them, D0, D9. That's going to give kind of a weighted set intersection of the 2 vectors. And that'll show us another view of the vertices that lie in between D0 and D9 in the graph. Again, where the weight indicates how many paths there are, both from D0 and D9 to the vertex in question. So that's about all the time I have. I hope you found this interesting. If so, check us out at franz.com and tinkerpop.com.